So now we're going to talk about multiplying monomials together. We've been adding and subtracting them, and now we're going to multiply. Just as a start, I want you to look at these first two problems and copy these down. We have 2 to the third times 2 to the fifth would be the first one, and 2 to the third power is 8, and 2 to the fifth power is 2 times 2 times 2 times 2 times 2, 5 times, or 32. Alright, little sidebar. It's a good idea to recognize and know your powers of 2. Basically, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, and 2 to the sixth is 64. These are things that you should recognize and know. Just like your multiplication tables. You should be able to get these a little bit quickly. As you get more advanced, you'll start to do 2 to the seventh is 128, 2 to the 8th is 256, 2 to the 9th is 512, and 2 to the 10th is 1024. And before this course is done, you will have those pretty well memorized because we use them a lot. So back to this problem, 8 times 32. 8 times 32 would be 256. And if I look at what 2 to the 8th power is, that is in fact 256 as well. Kind of matching over to my powers of 2. Number 2, I have 3 to the second power, which is 9, times 3 to the third power, which is 27. 9 times 27 is... well, let's look at what 3 to the fifth power is. 3 to the fifth is 81 times 3, because 3 to the fourth is 81. So that's 243, and that's the same thing as 9 times 27. So there is a little bit of pattern going on here. And if you look kind of at the point of this whole thing, if I have x to the third times x to the fifth, that's the same thing as x times x times x times 5 or more of them, which is a total of 8 of them. So this is the same thing as x to the 3 plus 5, or x to the 8th. The point of this is that when you multiply with the same base, and this is crucial, if you look at all of these, they had the same base, you add the exponents. Since exponents act like how many times you're multiplying, you're going to add up how many times you're multiplying it to get more times. So we look at same bases here, kind of like terms, but it's a little different. I'm still going to use the underlying strategy and say I have 3 to the third times 3 to the second. That's going to be the same thing as 3 to the fifth. And then 2 to the third times 2, well, that's really 2 to the third times 2 to the first power, which is going to be 2 to the fourth. Now, I know you guys are crazy about answers. This is illustrating a point that going from there to there simplifies it a little bit. But 3 to the fifth up above we said was 243, and 3 to the fourth is 16. 243 times 16. Well, one of the things you can do if I want to do this in my head is not to multiply 243 times 16, but to multiply it by 2 4 times. They may not seem easy, but if I double this 4 times, I get 486, then I get 972, then 1944, and 9 times 2 is 3888. That'd actually be 3,888. And I just got that by multiplying it by 2 times 2 times 2 times 2. Okay, number 2. Since we have y as a base, we're really just going to be simplifying. How many exponents do we have? This is the same as y to the 4 plus 1 plus 2. You're adding up all the 3 exponents, which means that this is y to the 8th, or 7th. Why is that? Think about this as y times y times y times y. There's 4 of them, times another y, and then times 2 more. And then you're just kind of bringing this right back down to y to the 7th power. The order of operations does come into play here. Now, with 3, this is the same thing as just saying m times n squared. times m squared times n. There's no difference between putting it in parentheses or not because of that associative property of multiplication. It says it doesn't matter how we group things. Furthermore, it doesn't matter how we order things, so that's going to give us an m cubed, and then this is going to give us an n cubed. So your answer is m cubed, n cubed for simplifying. Number 4, this is the same thing as 4n to the third times negative 5 times n squared. We can use our commutative property to move these together and make those negative 20. Then you still have an n cubed and n squared. And that can become n to the 5th power. Not 6th power. That's a common mistake made. Do not ever make that n to the 6th power. You don't multiply your exponents when you're multiplying with two different monomial parts that have the same base. Number 5, we got negative 7 times 3 is negative 21. X squared times x to the 4th is x to the 6th. We're adding exponents. And y to the 3rd times y is y to the 4th. Don't freak out when you see fractions. 12/5 times 10/3 would be our coefficient. I'm going to keep those grouped. A to the 3rd times a to the 4th is a to the 7th, and b times b is b to the 2nd. Now we can cancel, just kind of directing attention to here. If I make that 5 and 10 become a 1 and a 2, and make the 12 and the 3 become a 1 and a 4, and 4 times 2 is 8, I end up with 8, a to the 7th, b to the 2nd. Continuing on, looking at my coefficients, 20 times 12, 20 times 2 is 24, so 20 times 12 is 240, x to the 5th, y to the 6th. Don't go so fast that you miss the plus sign. That means we're going to have to do the left side here and then the right side as separate ones. But this isn't that bad. Negative 16, x to the 5th, y to the 4th, plus, I have a 1 times 7, so that's a 7 as a coefficient, x to the 5th, y to the 4th. Now, these happen to be terms that are two terms that have the same variables to the same exponents. We call those like terms. And since they're like terms, we can add them. Negative 16 plus 7 is negative 9, but we keep the x to the 5th, y to the 4th. When adding like terms, should put an ing there, when adding like terms, only add the coefficients. It's going to become increasingly important that you keep straight which operation you're doing and what the rules are for that operation. The rules for adding are different than the rules for multiplying. Number 9, I have to do this left side first and then this right side second. Negative 20. So ABC, A to B, that's 5 plus 1, A to the 6th. B to the 1 plus 3 is 4, and C to the 1 plus 3 is 4. Negative 2 and 3 make us the negative 6, so minus 6. A to the 2nd times A to the 4th is A to the 6th. B to the 4th is the only one present, and then C to the 4th. These are also like terms, so negative 20 minus 6 is negative 26. A to the 6th, B to the 4th, C to the 4th. 10 is confusing because your variables your bases have variable exponents. So what we're just going to do is keep the rule the same. That's really x to the 1st power, and if I look back above, when you multiply with the same base, you add the exponents. So this is x to the r plus s plus 1. You haven't seen an exponent that is itself an expression, but if you go to your calculator and you look at what the calculator shows when you punch up your exponent, you would actually see x to the, and it has a little expandable box in there. That's because this thing here, that is a grouping. That actually follows the order of operations as a grouping. Whatever happens in that exponent has to happen first because there's a grouping there. Number 11, if I want to show this out, this is 5 to the 3 plus x minus 3. 3 plus x minus 3 is just x, which is 5 to the x power. Number 12, this is negative 3 to the first power, negative 3 to the x minus 2. So the whole thing is negative 3 to the 1 plus x minus 2. I'm adding the exponents. In all three of those, I'm adding the exponents. That gives me negative 3 to the x minus 1. Now, the way I wrote it here would actually be incorrect because I did not group the negative 3 as a base. This is different from this because the left one could be positive depending on what the x is, but the right one will always be negative. So we have to keep our bases grouped if we're really truly going to say that it's the same thing or that's a different thing. Number 13. I have the same base, 2 to the x minus 3 plus x plus 4. This becomes 2 to the 2x plus 1. And that's done. I can't simplify. I can't make that 2 squared become a 4. We just keep the same base. Something to keep in mind here, this is not the same thing, or this is different as well. If I were to say, what is 2 to the 4th times 2 to the x, people will really want to make that 2 times 2 here be a 4, but that would be incorrect. The answer there would be 2 to the 4 plus x, and you just leave it. Another thing that we want to make note of is that if I have 3 to the x times 2 to the y, I can't do anything with those because they're not the same base. So that would be kind of a done thing. We would just leave it. Number 14. Don't freak out about these. You guys did pretty good on these in the final. The consecutive integer problems whose sum is the square of 6. We're going to say let x equal the first consecutive integer. That means x plus 1 is equal to the second consecutive integer, and x plus 2 is equal to the third consecutive integer. These are not consecutive evens or odds, these are just consecutives. Whose sum is the square of 6. Well, the square of 6 is 6 squared. That's another way of saying that same thing. It's just a terminology thing. And a sum means plus, and is means an equals. Put that all together, I have x plus 1 plus x plus 2 equals 36. Add my like terms. 3x plus 3 equals 36. Subtract 3 from both sides. 3x is equal to 33. Divide both sides by 3. X is equal to 11. And the integers are, plugging 11 back into the three different ones, 11, 12, and 13. Find two consecutive odds whose sum is the cube of 4. Let x equal the first consecutive odd integer. And then, if you remember from last semester, never, ever, ever, ever will we do x plus 1, x plus 3. This is actually x and x plus 2. Odds follow the same pattern as evens. You have to add an even number to get to the next odd number. X plus 2 is equal to the second consecutive odd integer, whose sum is a plus, is equals, cube means to the third power. So that is 4 cubed. So x plus 2 is equal to, what is 4 cubed? That is 4 times 4 times 4, or 16 times 4, or 16 times 2 times 2, which is 64. 2x plus 2 is equal to 64. 2x is equal to 62. X is equal to 32. Made a problem. This should be a 62, which means this should be a 31. I didn't end up with an even number or an odd number, which was kind of a problem. Okay, if x is 31, that means the numbers are 31, and 33. Next one, we have 4 consecutive integers. Let x equal the first, ci, x plus 1, x plus 2, x plus 3 are respectively the second, third, and the fourth consecutive integer. The sum of the two greatest, these are the two greatest, x plus 2 and x plus 3. So their sum, x plus 2 plus x plus 3, equals 17 less than, it's a minus 17, twice is 2 times, the sum of the two smallest, x plus 1. Simplify the left and simplify the right. 2x plus 5 is equal to, I'm going to go inside the groupings and do 2x plus 1 minus 17. Distribute the 2. 4x plus 2 minus 17. Continue simplifying the right. 4x minus 15. Let's subtract 5 from both sides. So I have 2x is equal to 4x minus 20. Subtract 4 from both sides, 4x from both sides, and I get negative 2x is equal to negative 20. And divide by the negative 2, so I get x is equal to 10. Which means that the numbers are 10, 11, 12, and 13. Lastly, we have 4 consecutive odds. Let x equal the first, COI, x plus 2, x plus 4, x plus 6 are the second, the third, and the fourth consecutive odd integers. It says the sum of the two greatest, that's x plus 4 plus x plus 6, is 4 times the smallest. Well, this one's an easy problem to solve. 2x plus 10 is equal to 4x, or 2x equals 4x minus 10. Negative 2x is equal to negative 10, and x is equal to 5. That is an odd number, so we know we're probably okay. And the numbers are, oops, no comma, 5, 7, 9, and 11.